students, welcome back to the YouTube video lecture series Fundamental of Physics for our Jubail Industrial College students. Today we are going to start chapter number 15, which is electric forces and electric fields. It's all about electrostatics. Electrostatics mean electricity attracts the charges. We study the charges at rest. If you look at this, the title slide, this is a night-time view of the lightning on the observatory in Arizona. So during a thunderstorm, high concentration of electric charge in a cloud creates electric field between the cloud and the negatively charged Earth's surface. So this is how the charges are induced. If I give you another example, the basic idea how the charges are induced, you see, I have pieces of paper, this yellow color, pieces of paper, and pieces of paper, they have the mixed charges, positive and negative, right? When I bring the cone near to them, you see right now, nothing is happening, right? Okay, but when I use it on my hair, negative charges from my hair, they are transferring to the cone. Now it is negatively charged and it will attract the positive side of the paper pieces. You see here? You see? So it attracts the pieces of paper because this is negatively charged. It attracts the positive charges near its surface. So this is how the charges are induced. The topics we'll be discussing today: electric charges and their properties. Then we will discuss two rules and two types of calculation we'll be doing and then comparing this. Keep in mind, I will refer it to you to this slide again, that when we discuss 2-point charges, we use Coulomb's law to find out the magnitude and direction of the force of attraction or repulsion between the two charges, and then we calculate the force of attraction between any two particles, two objects, with the help of the universal law of gravitation, then electric field and its strengths, and then we'll discuss electric field lines one by one. Properties of electric charges. We have positive and negative charges, and we know that positive, if you have both positive charges or both negative charges, they will repel each other, and if you have one positive, one negative, they will attract each other. In the vector form, we can show them like this one. If you have two charges, Q1 positive, for example, negative charge Q2, both exert a force on each other. The magnitude of that force is the same. Okay, the force on 1 due to 2, the force on 2 due to the charge 1. Magnitude is the same, but they are in the opposite directions, the negative sign for the opposite directions. Okay, so R is the distance between the center of the two charges. Okay, now the scientists have worked very hard to calculate some physical constants for the atomic particles, like proton, like neutron, like electron. So they concluded that the charge on electron and proton, they have the same magnitude. You see the same magnitude, but electron has the negative charge and proton has the positive charge. Neutron has no charge. The unit for the charge is Coulomb. Now, the mass on the electron, this much, and the mass of the proton and the neutron are the same. So these are the physical constants and you will be given in the exam, don't worry. These are the constants will be given to you in the exam. So let's talk about the first law of those two I promised in the beginning. So this is Coulomb's law. Now, it states that the force of attraction between the two point charges is directly proportional to the magnitude of product of the magnitude of the charges Q1 and Q2 and inversely proportional to the square of the distance between their centers. This is the line joining the two centers. Okay, so if I combine these two, I would write Q1 multiplied by Q2 over R squared. And if I remove this symbol of proportionality, I must write some constant K. This is not spring constant, okay? This is called K is the Coulomb's constant. Okay? Q1 and Q2. By the way, I'm taking the example of positive and negative charge, so there will be attraction. You may have both positive, both negative also. Right. Now, this is the force is equal to K, Q1, Q2 or R squared. These are the two charges. The unit is Coulomb for everyone. The force unit is Newton. This is the constant again, it will be given to you in the exam. Normally we have 8.99, but we round it off in many cases. So 9 times 10 to the 9 Newton, meter square per Coulomb square is the constant value, Coulomb's constant, our electrostatic constant. Now, so as I told you, we round it off sometimes 9 times 10 raised to the power 9. Okay? So it will be given to you again. Right. So let's use this rule to do one example. This is the first example in your book, in this chapter. And before going to solve this example, give me 1 minute to explain the other rule I promised with you that I will talk about that rule. So universal law of gravitation. As we have seen that Coulomb's law works for, force of attraction or repulsion. When you have one positive, one negative, you have force of attraction between the two charges. When you have both same charges, like both positive or both negative, you have force of repulsion between the charges. Coulomb's force can be attractive or repulsive, right? But this force between any two particles, any two objects, right, is always attractive force. And if you have one object, M1, before Q1, Q2 the charges, now the point masses, M1 and M2, like this one, M2, M1, for example, right? Distance is R, right? So the rule says that F is equal to, this is the gravitational force, and for electrostatic force we use F sub E. So this is G M1 M2 over R square, right? Before you have Q1 Q2, now you have M1 M2, the masses. Before you have K here, Coulomb's constant, now you have gravitational constant, which is G. It has the value 6.67 times 10 raised to power 10 raised to power minus 11 Newton meter square per Coulomb square. This is the universal law of gravitation. We needed to solve these two rules, Coulomb's law and the universal law of gravitation. We needed to solve this example. So I'm going to do this example now. Yes. Okay, the electron and proton of hydrogen atom are separated by a distance about this much. So this R is given to you. Find a part of the question. Magnitudes of electric force and the gravitational force. Okay, electric force and gravitational force. Right? Now, we have electric force we just finished. K, Q1, Q2 over R squared. You see, you have this animation for hydrogen atom. This is the nucleus, right? You have one proton here and one electron is moving with very high speed around this nucleus. So the radius is given to you, I mean between its center to this one is R, which is given to you 5.3 times 10 to the minus 11. Alright, now you know that Q1 and Q2, the charge on the electron and proton both are the same, which is equal to 1.6 times 10 raised to power minus, 11, 1.6 times minus 19 Coulomb. Minus 19 Coulomb is the charge on the electron and proton the same, right? So it means I can write Q1, Q2 both equal to E, which is the same magnitude I told you in the beginning. It is constant. It's not given here, but it will be given to you as I told you. Don't worry that it's not given because it is given in the table while you are using the book. Now, 9 times 10 raised to power 9, which is the constant. Okay. Or since it is given here, 8.99, no problem. Multiply by 1.6 times 10 to the minus 19, which is square because Q1, Q2, which is E square, same charge. R is given to you 5.3 times 10 to the minus 11. Okay. So it will be given to you K is equal to 8.99 10 raised to power 9 Newton meter square per Coulomb square. This will be given, this will be given. Okay, these are given to you. Alright, and it's square. So you get electrostatic force 8.2 10 raised to power minus 9. So this is your magnitude of the electric force. Now we are going to do the gravitational force. Gravitational force is equal to G, we just finished, the gravitational force between the 2 point charges. So G is given to you 6.67 minus 11. M1 and M2, okay, M1, which is the mass of the electron, and M2, which is the mass of the proton, are also given. Electron mass is 9.11 minus 3 minus 31 kg, and the mass of the proton is 1.67 minus 27. All these things are given to you in the exam, don't worry. So M1 9.11, M2 this much, R square into minus 11 square. So you get the gravitational force between the 2 point masses, proton and the electron. It's 3.6 minus 47. All right. So you see 10 to the minus 9 Newton. This is minus 47. Which one is bigger? Of course this one. So this is very strong force as compared to this one. Okay? And then you have to find out the ratio of the electric force to the gravitational force. So then we have to find out the ratio here. Okay, electric force to the gravitational force. So electric force you just finished 8.2 times 10 to the minus 9, and the gravitational force 3.6 times 10 to the minus 47. So you can find out, you will get the result 2.339. It has no unit because Newton cancels out. Second part of this example. Yes. Yes, compute the acceleration of the electron caused by electric force and then caused by the gravitational force. So you are going to find out the acceleration of the electron, okay, caused by the electric force, and the second one, acceleration caused by the gravitational force. So we have F is equal to ma. You got A is equal to F over m. Since we are talking about, the mass of the electron, okay, so acceleration of the electron, so force on this and its mass. Force we just finished in part A, which is 8.2 times 10 raised to the power minus 8, or its mass of the electron is given, which is 9.11 10 raised to the power minus 31 kg. So you will get 9 times 22. This is the mass, this is the acceleration caused by the electrostatic force on the electron. Similarly, we have acceleration due to gravitational force This is the electrostatic force and this is the gravitational force and the mass of the electron. So we calculated this force 3.6 into 10 raised to power minus 47 and divided by the mass of the electron, the same here. So you get, this is acceleration, so meter per second square. So gravitation, the acceleration caused by the gravitational force for the electron, it comes to the 4 times 10 to the minus 17. Okay, so you see the electrostatic force was stronger, so larger value for the acceleration. Gravitational force was weaker, so you have small value for the acceleration of the electron caused by the gravitational force. All right.